Let's work through an example using the Lensmaker equation and the magnification equation. In this example, we've been told that the object's height is 13 centimeters. HO is object's height. The distance the object is from the lens is 33 centimeters. DO is the distance of the object from the lens. The focal length of the lens is 13 centimeters. You're being asked to find where the image will form and what the magnification. Sketching this out, since I have a positive focal length, I know I have a converging lens, and I know my focal length is here on each side, and that's equivalent to that 13 centimeters. And I know that my object is 33 centimeters, so I know my object is out here a good distance away from the lens. So the light's going to travel in and pass through the focal point, and that's how the light is traveling and how the lens will bend it. And I have another one, and let's do one more, and we will have an image somewhere about right here. It's not important that you sketch these correctly because we didn't have an opportunity for ray tracing, but what you do have is the lens equations, that 1 over the focal length is equal to 1 over the distance of the image from the lens plus 1 over the distance of the real object from the lens. This is the object, and this is my image. And taking what information I know, I have 1 over 13 centimeters equals DI, which is one of the things I'm trying to find, plus 1 over DO, which is 33 centimeters. I take 1 over 13, or I'll do the math out. 1 over 13 equals 1 over DI plus 1 over 33, or 1 over 13 minus 1 over 33 equals DI, 1 over DI. This is 0.0466 equals 1 over DI. Let's multiply DI on both sides. Here it cancels out, so 1 equals 0.0466 DI. To get DI by itself, we'll divide both sides by 0.0466, or DI is 21.45. So this distance from here to here is 21.45.